Hello. I will. My name is Ayman Elmi, and I will talk about what is LED. LED is a abbreviation for light emitting diode. So it's a diode which is a semiconductor device that only light up if and only if a current pass through it in the correct direction, with this from anode to cathode, from the positive to the negative side. Okay. LED referred as solid state lighting because there is no filament or halo gas, which is halogen gas or noble gas, to light it up. So filaments such as the traditional bulb, there's something in between the in the bulb, and halo gas is like fluorescent bulb. So LED doesn't have any filament nor halo gas. So it is a solid state lighting. So it light up because of recombination of free carriers in the semiconductor. Next. There are few advantages of LED compared to different lighting method. First, energy efficiency, because it produces higher lumens. Lumens is the counting, is the to count light, is a unit to count light. So produce higher lumen. Next, withstand lower temperature. So LED work in perfect in normal parameters compared to another lighting lighting another lights, because in filament and halo gas require high voltage to operate in lower temperature. Third, longer lasting. LED is proven to be longer lasting compared to traditional bulb and fluorescent bulb. And also LED is sensitive to switching, so it can turn off and turn on very quickly, depend on the how quick we flip the switch. And also design flexibility, because there are multiple type of LED, such as a smaller one and a larger one, so it can be mix and match to match its purpose. And lastly, it dimming capabilities, because the LED is switching sensitive, so it is very sensitive to voltage given to the LED, so it can dim and bright according to the voltage if paired with the CPU or controller. Right, how does LED works? Okay, I will tell in forward bias. When forward bias, current flow from anode to cathode. So the current flow to the right side according to this image, from the plus minus to the negative, to the minus sign. But the electron flow is opposite of the current flow. So electrons move from the minus side to the positive side. So in the electron hole pair, there will be a recombination of the free carriers. So when the recombination occurs, they release photons. Such as in the bottom picture, the top right is the electron moving downwards to the valence band to the of the p side. So it recombine and produce photons. So when photons is produced, so light is emitted from the LED. So opposite to reverse bias, when reverse bias occur, the electrons are flowing to the other side, and the recombination will not occur. Thus, the light does not emit from the LED. Next.
Okay. Now I want to talk about how PN junction occurs in LEDs. So we know that the junction is the assembling of two semiconductors of different dopings and N and P types. So when the two semiconductors have the same band gap, they are called homojunctions. And when the semiconductors don't have the same band gaps, they are called heterojunctions. Okay. The LED is basically a special form of PN junction that uses a compound function. Okay. So in a PN junction diode, diffusion of particles leads to the formation of a depletion layer and a potential barrier that prevents further flow of particles. So semiconductor materials used for the junction must be a compound semiconductor, which means we know that this needs to be between gallium arsenide or gallium phosphide or indium phosphide. The commonly used semiconductor materials, including silicon, aluminum, are simple elements, and the junctions made from these materials do not emit lights. Instead, compound semiconductors, including gallium arsenide or indium phosphide, junctions made from these materials, junction materials, emit lights. So these compound semiconductors are classified by the valence bands of the elements they occupy. So the light emitting diode emit lights when it's forward biased, as Elmi mentioned earlier. So when a voltage is applied across the junctions to make it forward bias, so current flows as in the case of any PN junction. So holes from the p-type region and electrons from the n-type region enter the junction, and it recombines like a normal diode to enable the current to flow. When this occurs, the energy is released, and some of these energies turns into photon lights. Okay. So it is found that the majority of the light is produced from the area of the junction nearer to the p-type region. So as a result, when the design of the diodes is made such, so this area is kept close to the surface of the device as possible to ensure that the minimum amount of light is absorbed in the structure. That's all from me.
And I will continue to explain about band gap, the difference of band gap, and how band gap is connected. I will affect the LED. So first we had the direct band gap. So when direct band gap, there is more efficient recombination of carrier. So which means light is easily to turn on and turn off, and compared to indirect, less efficient recombination carriers. And also there's difference in band gap will produce different light, such as on the right one. So different material will produce different light color.
Okay, next is the types of LED. So we have several types of LEDs, and I picked 5 of it: homojunction, heterojunction, double heterojunction, quantum dots, and the live one. Okay, so for homojunction, it is use the same material which has the same band gap. And the material, however, doped differently as p-type and n-type semiconductor. So it has 2 different materials. Okay, so for heterojunction, heterojunction is usually used to increase the efficiency by confining the carrier in a small spatial region. The gallium arsenide is sandwiched between aluminium gallium arsenide. So as you can see here in the picture, it has the similar concepts of quantum well, where the electron is trapped into the small spatial regions, and those regions are has most recombination occurred. Okay, next is double heterojunction. Double heterojunction is actually it is to increase the output light and the junction of two different material. Okay, without bias and with bias. Okay. In it distinguishes between a heavily doped N-type and P-type. In the absence of a bias, the Fermi energy is uniform. So, but when the forward bias is applied, the height of barrier is reduced of the junction, and the electrons from the left can climb up to the gallium arsenide layer. So most of the recombination will occur here. Okay, next is quantum dots. Quantum dots is used to increase the efficiency by confining this carrier in a small special region. Quantum dots LED are usually used in TV and it has a higher quantum efficiency since the carrier are localized in gallium arsenide. Oh my god. No. I forgot to change this. So quantum dots is actually mostly used in TV and Li-Fi. Next is the Li-Fi, light fidelity. So Li-Fi is the wireless communication technology, depends on the use of visible light between blue and red color. It uses the light spectrum to transmit the data. Next is performance parameter. First we have the LED color. So each wavelength of each material has different color spectrums. It will emit different types of color, and a slight process variation could cause slight color variation, which could be noticeable. Next is luminous intensity. It is assumed as a point of source of light. It is like a light that emitted towards the specific direction within an angle. As you can see in the picture here, luminous intensity is this one thing, the lights coming out. Next is luminous flux. The luminous flux is usually interprets the sensitivity of human eye by taking the power of each wavelength present in the lights. We have and then we have illuminance. Illuminance is the space that is reflect the lights. And we have the luminance. Luminance is the eye that catch the light. Okay, next is current technology. Brother, you are muted.
Okay, sorry. So we know that scientists have already developed techniques that allows a single LED to produce all three primary colors. So this has big implications for active LED displays, and which normally require three to four tiny or individual LEDs placed near each other to render the full spectrum of lights. So there are also some exciting technologies which are implemented in recent years. So one of them is this reversed LED cooling. So in recent research of LED physics, we can see that researchers run LED physics in reverse to create a cooling effect. So recently, a research team
30 seconds left.
Demonstrated that LEDs run backward rather than doing nothing. We can expect that a short range of cooling effect we can achieve. So next slide, please. So another technology we can.
Your time is up. Sorry, 15 minutes.
Okay.
but you haven't touched the other big points, 20%, which is the summarization. So you will lose 20%. Huh?
Oh no.
Uh,
The time is up. I give you 30 seconds extra.
Alright. I will explain the summarization in LED lighting. From Al-Maidah, ayat number 2. Yatanawalu alal birri wa taqwa wa la ta'awalu alal ithmi wa udwan wattaqullah innallaha syadidul iqab, which means we have to work together toward the fight of Allah and should not work together against Allah. So like free carriers in the LED, we have to work together to produce light or to not produce light. So if the free carrier just want to do what they want to do, so it's very bad for the LED. So the LED will become not functional and probably will be decommissioned. That's all.
Okay, thank you. I don't understand your summarization, but never mind. It will be in the Q&A. All right, so now we open to question, because brothers and sisters, you need to understand, I will not teach this subject, and this will be the main part of the maybe the final exam, these 4 devices. So I welcome everybody to ask questions. Okay, who wants to ask first? Make sure you understand everything. If you don't understand, take the time to ask. Each group need to ask at least 2 questions.
I want to ask question.
Sure.
What determines the color emitted from LED?
Color.
Can you mention who you want the question to be answered by?
Aiman Elmi.
Yes. You mean color such as the LED will light up colors like blue, red, or
Yep.
yellow.
Yep.
So do you want to ask what do I mean?
No,
How?
I actually asking what determines the color emitted from LED? How do you
Yes.
determine the color?
For the one color LED, the determinant will be the type of the semiconductor. Such as gallium arsenide will produce yellow. I think. And
Bugatti is yellow.
yellow. I think it's yellow.
If you don't know, you don't say. I will give 10 marks for telling wrong.
Okay. Gallium arsenide will produce a color, and indium gallium arsenide will produce another color. So there is the type determine the color of the LED. But for active color LED, such as color one LED that can produce many color, like sometimes it's blue, sometimes it's red. Probably because of it is because of the heterojunction, the multiple quantum well type of quantum well that is in the semiconductor. So when the carriers in a certain quantum well, they produce a color, and when this carrier in different quantum well, they produce another color, like that.
But quantum well is also the material, right?
Quantum well is material.
Quantum well.
Yes, it's material. Yes, of course. So
why do you need to mention differently? It's just the material that gives out different color.
Yes.
Regardless if it's active or active, no?
Yes. Is at the core, different type of semiconductor will produce different color.
What is the parameter in the semiconductor that gives out different color?
The energy band gap from the different type of semiconductor material.
Okay, next question.
Hello.
Salam.
So my question is, does the dome affect the color emit of LED?
Who wants to ask the question to be answered? It must be like everybody has the chance to answer.
I will ask for Tasnimul Hassan.
Can you ask again, Doom?
Yeah. does the dome affect the color emit for LED?
Oh, uh,
No.
uh,
No.
You need to mute yourself, Amy. We can hear you
Oh,
thinking.
sorry.
Hassan, this is time for Hassan. You know, when I mark, everybody will be the same mark. If one in the group don't answer wrong, I will so the whole, the 3, 4, 5, 6 of you, maybe 7, will get the same marks. Okay. So, but you can help if one your friend cannot answer, another friend can help, but I will deduct the mark already lah.
yeah, I don't think it affects, doping affects the color, color change.
Aiman, are you happy?
Um,
Oh.
I think not. That's not the answer.
Why not?
I think from what we have been doing, right? So the dome has specific effect to the color emit, right? So
What do you mean? They don't understand what you're saying. Aiman. By the way, Aiman and Maisara, their FIP is on LED. Okay, that's why they ask question. Aiman, what do you mean?
so so the dome it has its own material such as phosphorus, right? So for indium gallium nitrate, the
Nitride.
nitride, so the color is blue. Where the color emit and it when when the color emit is blue, but when it goes in the phosphorus material, it turns the color to white. So it changed the color. So that from what I understand, is it true, Maisara? Is your FYP right? Indium.
So the
What I mean is that you know dome is the cover of the anode and cathode. In for at the LED part, that is the dome, and this is your LED. So what I means is that the indium gallium arsenide, for example, supposedly to emit blue color, but when the color pass through the dome, it is filtered, so it doesn't emit the color blue. It emit white light. So what I meant is say that does the dome give effect to
are
the
you sure
color?
the word filter? Is it filter?
Yes, it do word filter.
Are you sure? I'm not
It is
sure.
written on the paper.
Huh?
It is written on the paper.
So it depends what you mean by filter. I don't like the word filter. So so the LED, do you understand the answer? Do you think you are right or they are right? Who's right? LED team, answer. Hassan is already out. I don't know where he went. So team LED answer.
I didn't understand. Is it dome, DOME or DOPE? Which one is the dome?
The one who asked the question, answer. Aiman. Dia dengar ke tak, Aiman?
DOME LED.
Dome, like the top part of the
Yeah,
LED.
the cover of the
I see.
semiconductor. Yeah.
Okay. No, okay. Just that is the miscom.
Okay, so let me answer the question. Basically, generally, I think even the question is not accurate. Aiman question wasn't accurate. So, so when you do Q&A, if the question is not accurate, you're supposed to ask the question. You can clarify the question before you answer. Because sometimes your friend will answer, they don't know, they don't understand about laser, LED, solar, so they'll just ask anything. So as a teacher, you need to make sure you understand what they're asking and answer correctly and precisely. So when he said don't change the color, he didn't mention that there's coating on the dome. So it very, very broad. If the dome has no coating, it will not change the color, right? Hassan was right. But if the dome has coating on it, the light that gives out from the device will be different. But technically, if we say the LED is not with the packaging, LED just the semiconductor device, we don't say that it changed color. But if you say the whole thing, including the packaging, which is the dome is the packaging. So because if you don't have the packaging, the LED, somebody will like, if there's no packaging, can you imagine the LED, the semiconductor LED without packaging? What happens is, the wire, the bonding, people can just, because it's very thin, you can just push it and then the wire will break. That's why you have a packaging to make it secure, right? So the packaging, so therefore the dome, to answer, will not change the color unless you have another material on the dome to change it to another color. Okay, next question. But it is beyond I think beyond the group to ask the question they will not know about the dome having another material on the dome. Okay, next question. If you don't ask question, I will deduct marks from the other group. A lot of marks.
I have a question. So you guys mentioned about direct and indirect band gap when it comes to LED. You said direct is more efficient, is better, but indirect is inefficient. My question is, are there any LEDs that use indirect? Is there like a special reason why they use it, or there's none?
Who should answer the question?
I think you need to ask who.
I'm sorry.
I think only Kamalia is not answering the question yet. So Kamalia answer.
All right, Kamalia, please.
Is there any indirect band gap LED, right? The question.
The question is, are there any LEDs that use indirect band gap?
Usually indirect lighting is used on LED strips, like the strip one, because it's indirect band gaps is because we have two different types, right? We have photon and we have phonon. So like the one that it moves, so it creates delay for the lights to be emitted.
I understand, but the question is like, are there so are they used? Like, are there LEDs that use it, or they don't use it? Like, or is it a special case where it's used for a special reason? Or
1 second.
What's the answer?
No.
We don't hear anything from you, Kamalia.
No, because
Your internet is quite bad and we cannot hear. Okay, you want to type?
should I stop?
We cannot hear.
oh, she said no.
So what is no? What is no to what? So you're saying there's no LED with indirect band gap, Kamalia? No to
Yeah.
the LED with indirect band gap. So what to extend the question? So why does why does Hassan say that there's you know, not Hassan, I can't remember who said that is inefficient recombination. What does it mean, inefficient recombination? I don't know who presented that just now. Kamalia? Alah, tak dengar lagi ya. You need to type. What does it mean by inefficient combination? Faster. Yeah, somebody presented just now. There's the band gap slide. Kamalia? What does it mean in the inefficient recombination? Still waiting. Cannot hear you. Is it the internet or the microphone? The carrots are excited to the other plan? No pula. Ayah, how? Make up your mind. What is inefficient recombination? Because I don't know, your group that presented that one, you're supposed to know.
Inefficient. Can you hear my voice? Inefficient recombination means that the carrier is not being excited correctly.
What do you mean not excited correctly?
I mean, for indirect band gap, we have like it is indirect, so the output of the LED, the semiconductor, will be in terms of phonon.
Why you say it's not efficient?
Because LED is supposed to emit light.
Not efficient means that it emits light but not much. That is what it's not efficient means. But you're saying just now LED don't use indirect band gap material. You are contradicting yourself.
It's not using. What?
Okay, never mind. Actually, the statement is wrong. I'm telling you, inefficient recombination, the statement is wrong. I will deduct marks for that. I don't know where you get it. Okay, next question. So it's not inefficient. There's no recombination. If you talk about in terms of LED, there's no photon from the indirect. So why you say it's not efficient? You understand what efficient means? This will be my next question to Elmi. What does efficient means for an LED? That it should be part of your parameter, but I don't see it's a part of your parameter.
Efficiency of the efficiency of that when direct band gap. What is the efficiency to LED? Yes, is it?
Yeah.
What's the question? Yeah.
What is efficiency in LED?
Efficiency to recombine and for the carriers to recombine.
What does efficiency means in the LED?
Voltage power voltage.
What does efficient means in LED?
What kan recommendation.
Do you know there's equation for efficiency for LED?
No, I do not know that.
And how come? It means that you don't do the parameters, your assignment carefully. Efficiency is one of the most important parameter for LED. So anybody in the group can answer what does efficient means in LED.
Efficiency of an LED indicates the ratio between the energy consumptions and the
What?
Yes, Kamalia.
and the luminous flux emitted in the lumen.
What is efficiency in LED?
Efficiency is the ratio between the power consumption and the luminous flux emitted,
Okay, explain what does it mean?
meaning that
It's how brightness.
the
Huh? Hilang dah suara awak.
Is it brightness of what?
So your friend say brightness, huh? Kamalia, did you explain to your friends the parameters? I told in the everybody need to know the slide of everybody else. Kamalia? Because if your friends don't understand, the whole group doesn't get the marks. There's a problem if for group presentation. You all of you chose group presentation. You're supposed to teach each other until each other understand, so that I can so what is efficiency? Mana Hassan? Hassan already out? Not coming.
Hassan cannot connect it.
Ya Allah, poor Hassan. So
he's texting that can you please let him in?
let's let him in. Oh, okay. Alright. Alright, so what is efficiency, Hassan, in LED?
Efficiency.
How do we say the LED is efficient or not? What determines the efficiency?
Efficiency. How the efficiency of an LED is the ratio between the electrical power consumption and the
Hassan?
Power consumption and photon. The brightness.
The brightness.
Brightness.
You need to be careful because brightness have lumens. You have like what's the difference between lumens and the number of photons coming out? Is there any difference? These are very, very specific things. So basically efficiency. Okay, efficiency means that for every current, how do you get light coming out from LED? What do you do to the LED?
We give power source to the LED. And
what do you mean by power source? What do you do?
I mean voltage.
How do you connect the voltage to the LED?
In the negative and in negative junction, in the forward bias junction.
Answer is forward bias. So you forward bias the junction by applying a voltage source.
Yes.
To it. So then you will have, because another thing, when you are mentioning about how the LED works, I'm not very happy because that is where most of the marks are. I'm not very happy because you don't talk about diffusion. Did you say the word diffusion there? Both buyers have a lot of diffusion, no?
Yeah.
So why didn't you mention about diffusion? You
We
learned this when in the class. I
explained
thought
that much. Yeah. We mentioned about the word diffusion, but we didn't explain that much.
you okay, can you explain again how LED works? Kamalia. Allah, Kamalia, I don't know whether you can, tak ada voice pula, tak apalah, Elmi. So, I don't know, but if you have a presentation, maybe you need to ensure a bit if possible like your internet. Elmi, where you going? You're supposed to answer questions. Okay, never mind. While Elmi going, any more question from the floor?
How a specific color can be produced from a LED light? Suppose white or suppose red.
That's the same question that my Sarah was asking before.
It's mentioned earlier, is the wavelength and
Ask another question because the question has been asked. Other question? One person ask one question. Come on.
Is LED have different size of diameter for any purpose? It's like different size for LED.
Who you wants to ask the question to be answered?
Elmi.
Okay, let me answer.
The question is LED has different sizes?
Yeah.
Yeah. The answer is yes, and the purpose is because different sizes of LED will have different uses and consume different voltage and will produce different brightness, such as a small LED. We use for signaling whether the machine is turned on or turned off, and larger LED we use in torchlight, like torchlight, white torchlight. So it use larger LED and use larger voltage.
How do you know in the torchlight they use larger LED?
Because the size in the torchlight has larger
Maybe
LED.
they have many LEDs, but in series or parallel.
There is a smaller one in circuits. There's a smaller one LED in the circuit. So compared to a circuit one, there's a small one, very tiny one. And so in torchlight, there is a larger one.
How to know it's larger, as I said?
Because I Googled it. Is that the correct answer? Because when I see there's different size of LED and has different purposes. That's they say in Wikipedia.
Why you ask that question, Rahimi? Why?
Why? Because it should have different size for different purpose.
Okay. Actually the question is a bit if you think carefully the question, does it have different sizes? Normally we cut it very small, so because we can sell many, so the number of, then the question is what determines the brightness? Is it the size of the LED? Answer, Elmi.
The brightness, no, not the size, it's the voltage.
So why you say torchlight use a bigger LED?
It use larger type of LED. It use a larger type of LED.
I know why. So when you say that the brightness use it doesn't matter the size, no?
Yes and no.
What do you mean?
Because size, because when LED in torchlight, and there's a lot of LED in torchlight, Yes. The LED and torchlight compared to smaller in the circuit board. There's a just like a LED with not even a dome, just a cut, just a square LED, small LED.
So
In the
why in the torchlight they use bigger if you say it's bigger lah? Why?
because it's because it is bigger. I think it's a larger size, right? I did not see any torchlight with smaller LED than PCB.
The question is why?
Why? Because it is.
You don't answer that to a professor.
Is it because because of the
Any of your member wants to answer?
because the packaging of the LED.
Okay, when you say packaging, there's a technically you are not wrong. Because it depends on how you define LED lah. It depends on how you define the LED. I will define, because this is semiconductor device, I will define the LED by just the semiconductor device, not the packaging. But it's okay. I'll accept your answer, although not very concrete. So, okay. I think that's for today. I think that's, but still, my last question is on the Islamization. I don't understand. I don't see the relevance. I don't see this 20%. You want to, I give you another chance, your group, to give Islamization next class. Okay. Because I don't, Islamization is about what I said, Qulubul la yaqiluna biha, something like that, right? Use your heart to think, which is, this is difficult. But I want to see it now. Maybe you need to do Qiyamul Lail. 2 nights in a row. So maybe need more. Maybe Taubah, I don't know. 10 raka'ah also. So right. So
sleepless night is not worth it.
So maybe Allah wants to make you pray more. Okay. So I give you another chance on that. The rest of you, make sure your Islamization makes sense. Because why I will say your Islamization doesn't make sense? Of course, everything that Allah created other than human being, they just follow what Allah says. They don't have things. So your argument is not, doesn't make sense in the Islamization. But human being, Allah gives akal. That's why we can choose. Jinn as well. But the others, they will just follow exactly what Allah says. So it just doesn't make quite sense. Your Islamization part. Okay. I think that's all. I give you another chance on that. There are other questions, but we don't have time, which but the rest of you, the rest of you, I'm warning you, I'm not teaching this in the class. So you have to ask, make sure you learn from your friends, or you ask question in the class. Otherwise, you'll be in trouble in the final. So if you ask question here, your friend cannot answer, I will answer it. Right? But if you don't ask question, you don't understand, it's your fault if you cannot answer the final exam. That's how it works. So I want to force you to ask questions. So you need to anticipate what are the kind of, make sure you really understand the thing, especially how it works. Basically, you need to write down again, how does it work, even in the quiz or the final exam, exactly what the wording, what happens first, what happens next. Because there's no question that I assume you understand what your friend was saying, but it's okay if you understand. Make sure you translate that in the quiz or in the final exam. All right. So next group, the others, get ready for your presentation next class, inshallah. Okay, let's end the class today. It's a good effort generally. I would say the presentation is okay, but there are things which are, be careful when it's wrong. I'm very sensitive to things which are wrong. So for example, the inefficient, the wording that you use, be careful because it can mean it means it's wrong. You're not supposed to, if Not accurate can boleh diterima lah, can still acceptable, but if it's wrong, it's not acceptable. Okay, let's end with the doa, please.
Madam,
Yeah,
the password for today?
the password for today will be LED. Thanks to your group.
Thank you.
Okay,
Appreciate.
can we have a doa, please? So make sure you know how I grill, so make sure you prepare thoroughly your presentation next. Can I have a doa? Or we cannot leave? Whose turn is it? Maybe it's the third round, I don't know. I think it's in the second round. Wow, you love this class too much that you don't want to leave. Okay, so stay there. Okay, Ikram.
والصلاة والسلام على سيدنا محمد وعلى آله وأصحابه أجمعين. اللهم إنا نسألك سلامة في الدين وعافية في الجسد وزيادة في العلم وبركة في الرزق وتوبة قبل الموت ورحمة عند الموت ومغفرة بعد الموت. اللهم خلقنا في السماوات ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه والحمد لله رب العالمين.
Thank you, Ikram, although I can only see your hair. All right, so let's end this tasbih kifarah. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilaik. Bismillahirrahmanirrahim. Wal 'asr. Innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Thank you,
wabarakatuh.
madam.
Thank you, madam.
Ada